Hello everyone. So today I would like to discuss a very fascinating paper that I found a couple of days ago. It is a new technique to determine if a person is infected with malaria using physics. This actually, I'm giving the link of the paper below. This is from Rice University, a group from Rice University at Houston, Texas. And it uses two very fundamental concepts in physics: resonance and thermal expansion. Now, how resonance works basically. Well, people really like this example. Imagine you are sitting on a swing at a playground, and you have nobody to to push you, to help you. So you're by yourself, and you want to start moving back and forth on the swing. So you try to move your feet back and forth, but you do it at a erratic manner, or a random frequency. Well, go out and try it. It doesn't matter how hard you try it, you won't be able to transfer efficiently energy from your feet into the system, which in this case is the pendulum. It is only if you have your feet moving back and forth at a specific rate, at a specific frequency, that you will start seeing that some of the energy will become part of the pendulum energy, and you will be transferring this energy. And the more you do it, the higher the amplitude you get. So you will reach a point where you're sitting and you're moving your feet forward and back, synchronized with the natural frequency. In this case, we call this natural frequency of the pendulum, which in this case is the swing. And you will start gaining more and more and more and more amplitude. So the concept of resonance is basically that system will respond or will react to a driver only if the driver, it is synchronized to the natural frequency of the system. Otherwise, it will just basically ignore it. In the case like you're moving your feet back and forth randomly or erratically, it will basically ignore that. So the system will be invisible, or it will ignore any energy source with an input energy that comes with a frequency that is not the natural frequency. Now, about thermal expansion. Well, what happened is that imagine you have a system at an initial temperature. This temperature is not the absolute zero. It's not the 0 Kelvin. So you have some thermal temperature. Therefore, the atoms or the molecules inside your object, they are vibrating. They are actually moving. They are not completely at rest. If you increase the temperature of your system, you increase the TF is greater than TI, well, those molecules, what is going to happen is that they will now continue moving, but at a more or a larger amplitude. They have more energy, so they have a higher kinetic energy. In the case of a gas, that means that the gas molecules are hitting the wall of the container at a higher speed or a higher rate, so there's more pressure that push the walls away. And the effect of that is that now your system will have a larger volume. So the volume behaves just like the temperature. The higher the temperature, the higher the volume. That's the concept of expansion. Now, how these two concepts, the concept of feeding a system with a specific frequency, the system will respond, and once you have a increasing the temperature of a system, it will increase the volume, will help us to determine if a person is infected with malaria or not. Well, in this case, the way it works is the following. Imagine this is a red blood cell, and you have a healthy one and you have an infected one. And by infected, I mean you have this nasty parasite inside. Once the parasite is inside your body or inside the host, it will digest the hemoglobin, and it will produce or synthesize a new particle called hemozoin. Now, this hemozoin has a specific size and chemical properties that it has somehow a natural frequency. So you will have some sort of hemozoin natural frequency. Let's call it FH. Well, what you need to do is to get a laser that can send a pulse or a package of photons, very high energy photons, at this specific frequency. What is going to happen is that, for example, when you expose the healthy cell with this pulse of a laser or photons, well, none of the organelles or molecules inside the healthy one, it has this specific frequency for a resonance frequency. Therefore, they will ignore the package will just go through, and nothing will happen. Now, in the case of the hemozoin, when the particle is infected and it will contain hemozoin, this hemozoin, it is its natural frequency is synchronized with the frequency of the laser, and it will absorb that energy, and therefore will start heating up, and it will heat up so much that by friction with the surroundings, with the water, it will create a bubble. It's just like when you're boiling water, you see this bubble coming from the water. Well, that's actually a point where the temperature is high, that you create a localized gas, let's say, or vapor. Well, it vaporizes and it will create this bubble. This is how resonance will distinguish from a healthy one. It will ignore the pulsar. The infected one, it will create, you will have this bubble. So this is how the resonance plays a role here. Now, how the thermal expansion will help us. Well, in the case of the infected, once you have a region with a temperature gradient, so the temperature is very high in this region, this bubble, it will expand due to thermal expansion. It will, the molecules inside, it will start moving so fast that it will try to push out, and this will create a shock wave. And this shock wave can be detected by a microphone or a transducer. And once it is detected there, well, what we're going to have is that we connect the transducer into a oscilloscope, and then let's imagine that we shoot this laser pulsar at a specific time t of the pulsar. Well, we're going to have by putting the microphone near to the red blood cell, we're going to have a blast or a boom or the shock wave will register as a increment of the noise, and it's going to be correlated with the same time. So we have a link here when the laser was triggered and when my oscilloscope gave me a signal. In the case of a healthy red blood cell, it's gonna be, the microphone won't pick anything, and the signal will be just like random noise or like background. So this way, voila, we have that looking at the oscilloscope synchronized with a laser at a specific frequency. Well, we will be able, in fraction of a second, we will be able to determine if a person is being infected with the malaria or if it's a healthy person. Well, I hope you enjoyed this video, also find it really fascinating. And now I have a question. What other examples of resonance and thermal expansion do you know? I would like to hear from you, and so please just send your comments. I hope you enjoy, and thanks for watching. Bye.